Okay, in this video, we're going to introduce you to 3 different concepts related to translations. First is a straight up reflection, think mirrors. Second is a rotation. We talked a little bit about rotational symmetry previously. And a translation, which is just moving it to a different spot. So we're going to start with reflection. So a reflection is exactly what it appears to be. It's just imagining there is a mirror. It's somewhere around the shape, and then we're going to reflect it. I'm going to start by imagining there's a mirror right here. I'm going to use this line as my first line of reflection. So you can see the original shape here, and then I reflected it as though there was a mirror right in the middle, or I flipped it upside down, and the reflection is on the other side of the line of reflection I've created. Notice this sticky out bit isn't here, because in the reflection, if you imagine this is the mirror, the sticky out bit, there's a space. So between the mirror and the bottom reflection, there's a space between the sticky out bit. So now I've done another reflection. This time I've made the line of reflection a vertical line, and I flipped it from here over to this side. So as long I could do my line of reflection there, I could do it there. It's totally up to you, but you're imagining that mirror image. Next, we're going to talk about rotation around a point. So I've chosen to rotate around this point right here. So when I do that, I'm going to show you with a different shape. But if I had this shape there and I rotated, notice this part stays on that point. So I take the shape and I'd rotate it like this. So that would be a rotation of our initial shape here. That would be a 90-degree rotation. I could then turn the shape again, rotate it another 90 degrees or 180 from the original spot. You'll notice there's a little bit of a flip kind of look happening there. Or I could rotate it another 90 degrees, which would be, what's that? 180 plus 90 is 270-degree turn. Or we could just keep turning it all the way. Notice that corner stays planted on the point back to where it started, a 380-degree turn, 360, a full circle. If I wanted, I could change where my point of rotation was. Maybe I want to rotate from here. Same concept. Notice it changed. That corner now stays put. And oops, it's hard because it's going with me, but you get the idea. Should be like so. Then it would rotate again like so. Again, oops, like so. Or back to normal if it's a full 360-degree rotation. Always rotating around a specified point, okay? The last concept we're going to look at is translation. And you can kind of tell from this little picture title up here that the shape itself stays exactly the same. There's no flipping, there's no mirror image, there's no rotating, but it actually moves on the grid. So it would be like taking our shape here, keeping it exactly the same, but we're going to, same size. If we just moved it down here, for example. Often when we're doing a translation, they'll ask you to move a specific point. So they'll say move point A from 2 and 5, which we see here, remember 2 across, 5 up, to 5 and 3. So we've done that, 5, 3 up. So we've just taken the shape and literally moved it over. We haven't flipped it, we haven't rotated it. That is a translation. So just as a quick review here of what we've just said, we see first our reflection we talked about. This is just the image flipped as though this is the line of symmetry and the line of reflection, and this is the mirror image down here. This over here, we see our rotation. It's as though it is rotated around this point, 180 degrees. And over here, we have our translation. It's exactly the same looking shape. It's just moved over and down. Here we have 2 examples of questions that are asking about reflection. So they both say, look at the shape, which image shows a reflection? So I've just sort of copied the image that we had there. I'm going to try and keep it about the same size. and I am going to flip it. So we get an idea and we can look and see which one looks like a reflection. I'll do the same with this one as well. So using the program, I was able to flip the shapes. Both of them I just flipped up and down because I noticed that this, option C, looks very close, or it is the same. That would be that shape, the reflection, flipped up and down. So C is our reflection there, because that option B is just the same shape moved, so a translation. And option A, it's that shape rotated, not mirrored. Over here, I flipped it again up and down because I noticed that option B looked a lot like it was flipped up and down. So I'm going to say option B is our reflection, whereas option A looks like the same thing moved, a translation, and option C looks like a rotation. In these examples, we're looking at rotation. So it says, look at the shape, which image shows the rotation? So again, I've made a copy of the image. I'll try and make it about the same size. So we can try doing the rotation. Keep in mind, we're going to be rotating around a point. Oops, I want to grab the picture, not the big thing. Make it a little bigger. Okay, so it looks to me like the point, and this will be a little tricky to do, but I'm going to try my best, is right there. So in our graph, that's right smack in the middle. I'm going to make that dot a little smaller for the other ones. So we're rotating around the middle. So let's see which one it works for. So if I rotated that, whoops, around that middle point, it would end up being there. Nope, none of them match that. If I rotate it again, it would end up being there. Now that looks just like, sorry, it's hard to line it up, but the point which should be on the dot, that to me looks exactly the same as C. So I believe C is our rotation. And if we look at the other ones, I think this one, the shape has stayed the same. I think it's just been a translation. They've moved it from there down to there. Whereas this one, I notice, is actually a reflection. They flipped it along a line of symmetry right here. So the long way is now facing the different direction. Okay. In this last example, we have our sort of substitute shape here that we can move around. So that would be there. So we're going to try rotating it around that point in the bottom left-hand corner. So if I turn it 90 degrees to there, already I'm seeing that that looks exactly like option B. So I believe option B is our rotation. I'm going to keep rotating just to try it out. I rotate again. Sorry, it's hard to do it and keep it the same size. That kind of looks like C, but I think C is actually just a flip. This is the rotation because I noticed that the long line is on that side, so it's on the wrong side for it to be a rotation. I think C is a reflection. Whoops, daisies. This one is, I think, with the line of symmetry being there. And if I continue to rotate one more time there, that definitely doesn't look like A. Doesn't really look like any of them. And one last rotation back to where it was. So I'm going to say it definitely must be option B, which we saw looked, oops, daisies, go back. That dot should be there. Look like that, which matches this one. I think this is just the same shape translated, and that is a reflection. In this example, they're saying, look at the shape, which image shows the translation? So remember, when we're doing a translation, the shape itself doesn't change, it doesn't rotate, it doesn't flip, it stays looking exactly like this. It just moves. So we're starting here, so really this is the easiest one of all, because which is the only one of these shapes or options where the shape is the same? It's clearly B. And we can figure out that, well, it started in this spot. So in terms of translation, it's moved to the left 2 and down 1. Nice and easy. And of course, the same for this one. Again, not rotated, not flipped, or oops daisies. Not flipped, just which one has showed a translation. So doesn't look like that, doesn't look like that. Ah, looks like that one. So it started up here. This one has obviously gone 3 places to the right and down 1. The answer is C. Okay, good luck with this section.